So, how are things?
Things are all right. Let's see. How are you doing?
Okay. I think I
All
caught
right.
up with reviews, but
There's the one on adding the lint that is left.
yes.
And then what I was going to ask was, should I just completely separate out handling moves from the PR that I created for moves and mutability? There was some little bit of overlap, so that's why I've done them together. But should I separate them out or uh,
Did I tell you to?
like you didn't tell me to, but we are like the move we need to also add the reborrowing part, right? And like handle them a little differently because of the move. If the root variable is a reference, we want to do things a little different. So I feel like maybe separate it out and just doing it as a separate, like doing all these additions in a single PR might be more cleaner for someone to track down later.
I
But
feel like my ideal would be, it seems like the reborrowing, I'm a little bit concerned that one PR that does the move plus reborrow will be more complicated.
okay.
How much is the move work?
Moonbird right now is kind of small. Something needs to be reworked to handle what is it called? Uh, Changes to FN FN1s because once we start supporting reborrowing and all these, what we like the FN FN1s will change because we do not do the restriction and like we do not handle like we do not trim off whatever we need to trim off from our projections or anything like that until we are doing our min capture analysis, but we do our closure kind analysis on the fly. So something needs to go in there. And I didn't want to spend too much time early on this until reborrowing is implemented because like I feel like I'd be adding more complicated logic there to make it work and might be simpler down the road. Well, by down the road, I mean one PR or two later.
Mhm. Okay. Um, so I guess I don't have a strong opinion. If you wanted to pull the move out, I wouldn't object, but
Okay.
I also don't know if I feel it's necessary.
What I can do is I can leave a fix me that then once we do reborrow, we handle the closure kind.
Mhm.
Uh,
Yeah,
that might be,
this is a really long PR. I'm trying to remember
yeah.
why it's so long.
Because it's long
It's actually
because
more tests than anything else, I guess.
yeah, it's really just tests and also like just small fix me's in places,
Yeah,
which should
okay.
be
It's not so bad. I could try to review it tonight. Um,
okay.
to the extent that I haven't already, which I forget. What about, and then the other one is 80629.
It's the lint one, right? I updated to use drop
Okay.
and I let me go. But yeah, sorry. I want to talk about how we plan on implementing the reborrows. Like, do we just?
I think I'm just gonna R plus
Uh,
this lint one. It looks
okay,
like I already gave it a review and was pretty happy. So,
yeah.
yep. Okay, I'm just gonna do that right now. Um, so now, what was your question?
So, how do we plan on implementing the reborrow? So, we want to reborrow only in the case where our root variable itself is a reference, and we want to try introduce, and we end up
That's not quite right. Uh, it's not important if the root variable is a reference.
okay.
What we want, let's make a, do we have a document?
We can start a new one, and I'll just dump it in like the way we have been doing it.
There's an issue for this, right?
There is an issue for this, yes. So
Yeah. Can you make a doc and post it in the
I'll
issue?
I'll I'll do that. Give me 1 second.
Yeah.
Mm. handle mutability. Where is that? Yes, move out of reference and move pointers. And yeah, I'll send the. Okay, so doc I'm sending in the Zoom chat one time. Okay. And I'll post that on the issue.
Why? There we go. Okay, so let's make up some examples. Issue 31. I guess I should share, huh?
Awesome. That'd be a good idea. Yeah.
Well, let's do it. I'm using my what do you call it? This new, there we go. That looks right. The crazy keyboard strip on my Mac with changing buttons. Changes to share screen when you're in Zoom. Very exciting.
I did not enjoy that when I was doing. Yeah.
It's I don't hate it. I don't think it provides me with excessive value, but neither does it get in my way in particular. So at least there's a physical escape key. I understand that was a problem early on. So okay, let's look at the example. Yeah, this is a good one, a good enough one. Or this is an initial one. Let's start with it. So, right, so here's one example. Let me make a different one. And this is a case where the root reference is, so what do we have here? We have a and mute access to star s dot x, right? So the important thing I claim is not the fact that S is a mutable reference, but the fact that we, whoa there. Okay, I don't know what's happening now. That we passed through the deref of an mute value. And so as an example, consider this one. Here, we would have put the parens to make it clearer.
Yeah, we'd have.
And again, I think we would prefer, we would want to capture and mute star s dot x.
I see. Okay.
So what, yeah. So I think the rule we want is if you have a and mute access to a path, I'm trying to think how this works. What are the edge cases? So first of all, there's the annoying case of an and mute access to which has a deref of a shared borrow, which we know is an error.
So we can compute mutability of a captured place if we have, let's say, in a situation like this where we dereference a immutable reference on top of a mutable reference.
Right, and I don't know. We can certainly compute it. What I don't know is, should we? Like, I don't.
We need to do that for handling the mutability side of using mutable borrows outside of the case of moves.
Okay.
So like if you have a tuple that contains a mutable reference, if we mutate the structures via this, if we mutate some data while going through this tuple, then even if it's a mutable borrow, we would need to keep a track of mutability, because if the tuple is immutable, and I probably should be writing, otherwise this doesn't make sense.
Yeah,
so,
please write. That'll
yeah, sorry. So like if we have this, we have let as, let's just say it's a string. uh, that, and we do, and that just doesn't matter what this is. To be able to handle this, we need to compute the mutability of if this place start.0 is mutable or not. So we need to do that today.
Why?
Because the borrow checker a lot kind of special cases the mutability of uppers. And until today would only check if the root variable was mutable. So this is the other PR. This is the other part of the PR that's open as part of the move PR that we were talking about.
But what's confusing me is maybe I don't understand the word we, or we're being a little sloppy when we say we need to compute the mutability. Which piece of
So
code at what time needs to compute it?
so type check computes the mutability of start.0, and it's used by the borrow checker to figure out, and also I think used by mer build to figure out if this place is mutable or not. Because until
Oh,
today,
okay, okay. I sort of remember this. We have to store that because
it's
otherwise we get crappy error messages and we allow too much mutation, more than we actually
it's
want.
it's not just that. We also would, in this case, will say this place is not mutable because it will just look at the root variable today and say, oh, since t is immutable, the start of this place will be immutable. Because okay, so the error happens because of the same issue that we were kind of discussing last week. Is we see that a capture is being modified, a capture in its entirety is being modified. Uh, that is, we don't build a place on top of it. Therefore, the capture is mutable if the root variable of the capture is mutable. This used to work until we made our change because the capture and root variable were the same concept.
Yeah.
But
Okay.
going forward, since that is changing,
Okay.
uh,
All right.
that kind of breaks the.
Yeah. So that's fine. Uh, let's pop back the stack a little bit. um,
Yeah.
so I mean, just to summarize, if I understood, basically we are storing as part of the capture information the mutability
Of the
of
place.
that place that was captured so
Mhm.
that borrow check can take that into account.
Yes.
Yeah, that's fine. And that makes sense. What I don't know is um, if you have a mutable access, an ampersand mute access to a deref of a shared borrow,
Mhm.
the closure would normally capture it as an and mute,
Mhm.
but that's going to
It
give an
will.
error. What happens today?
Can you write an example? I think it will,
Actually,
as long as you don't mutate it, it will be fine.
let's defer this. Let's come back to this because I actually don't really care. Basically, there's some question in my mind of when we know that there's going to be an error, do we want to capture it with less permissions, or do we want to sort of let the error play out? And I forget how we do it, and we should look into it. But I'm more interested in this other question, which is how are we going to implement the full
Wow.
analysis? Like the other corner case, what happens, for example? So we're talking
Mhm.
about even in move closures,
Mhm.
right? Anytime, I guess only in move closures. This isn't relevant outside of a move closure. Uh,
This would be relevant if we have a by value capture.
that's what I'm trying to
So
figure out. Why and when? Okay, we might have a by value capture of the deref of an and mute. So, okay, let's kind of come up with some examples. So is this only relevant to move closures? And here's, so the reason I thought it was is if you did, let's say, that, then you're going to have and mute access to star s dot x, so you get a mutable borrow upvar, right? Mutable ref upvar. But if you have a move, that's we kind of want, that's what we're changing, because you would, without this, you would move s because you stop at the deref. And what you said was, what if you have a by move capture? And I guess that's what I'm trying to understand is, how would you have a by move capture such that this optimization or whatever applies?
I see your point.
And in particular, what I'm really trying to puzzle out is if there's both and mutes and moves to related paths, is that a thing?
I guess, yeah, another similar question here would be, what if I was actually just moving the path s dot x afterwards, right? Like I just call move s dot x.
Yeah. So there's a few
Then
possibilities. So maybe we can just work them out. One is you do something like this, which will be an error, mind you, because you can't move out from an mute. But one would be, what's the other field? Yeah, okay. One would be something like this. Maybe there's this is not, we have to, it's actually relevant. We should bring this. I'm going to go ahead and use. So this example is not that exciting because, well, it's interesting, but it's also an error. Right? I think, ignoring the fact that it's an error, what I expect is that this closure will mute ref s dot x, and, well, it would, I guess I take that back. I don't think it would move s dot y because we never move derefs.
It'll move s.
So I think it would just move s.
Yes.
And in that case, if you're going to move s, you don't mute ref s dot x, right?
Yeah. Also, s is a mutable reference, so it will, like that code will fail. But yeah, yes, this will do that.
So we can't move x dot y or s dot y. Right. And that's what I expect this to do. But what about this example?
Yeah.
What about?
So this will move s, right? No, this will move s dot y because there isn't a deref.
Yeah. So this, I think, would mute borrow s dot x and move s dot y.
Will it mute borrow s dot x because x itself is a mute reference, right? So it can just have an immutable reference to that mute reference. So it could have a shared reference to that mutable reference. Does that work? No, that would not work. Never mind. No, okay, you're right. You're right.
I think this is what I would expect it to do.
Yeah.
I bet this even works today. But this is not, really, it's not s, it's star s dot x.
Yes.
But this probably just works today, right?
No, this will fail because until my PR gets done, as far as I know.
Why would
like we can test it on Playground. Because the fix is not in. It's the same issue that I was talking about earlier with having to compute immutability.
Oh, okay, okay.
Because
With all pending PRs landed,
yes, this should work.
this would just work. I don't think this actually requires our special case, is my point. Like,
This one does not.
you're not moving s.x. There's no move of s.x.
Yeah,
So,
yeah. So I don't think that will. Yes, I think it's a move closure concern.
so I think it's really specific to move closures.
Actually, what if you have a box and then you move the reference there? So like if you had a box and you did star, like S was a box and you moved or
Like this.
S dot X, right? Yeah. No, like if S itself was a box, like
S is a box.
yeah, you have that in a box and then you move.
Then I think you're gonna move all of S.
Because we'll drop the DDoS.
Yeah.
Essentially. Okay. So the question is, when do we reborrow as well, right?
Yeah. So right now we're not like coming to any. These examples are not showing us any reborrowing. I'm trying to think if there is one where we expect to reborrow. I think, and it's not a move closure. And I think if there was, it might be something like drop s dot x dot something. But even there, I think it just kind of can't happen because the only time you would reborrow is when there's a deref in the path.
Mm-hmm.
And if you have a move of some suffix of that path, it will stop at the deref. And so
yes.
therefore, it's going to wind up moving the whole thing and your reborrow is not needed. The only case where I think this analysis applies is in a move closure. So my argument is if you have a move access to a place that involves a deref, we truncate the place at the deref. Maybe it's we should say, what is the reborrowing change? And my claim is it is specifically if you are in a move closure and you have mute ref access, let's just stick to mute for now, to a place that involves deref of an and mute reference. You will have a mute ref upvar for P. That's not quite right, I think, because I'm not accounting for other accesses to P potentially. But I feel like there has to be some analysis that's saying well, I guess what I'm saying is we have to talk about now the minimization, right? Your analysis already does something where it accumulates a list of accesses and then minimizes, is that right?
Yeah, it will do that. So that like the min capture analysis will happen. It will figure out the shortest path we should capture. Why are we not considering shared bottles here? Like
just to make my life simpler.
Okay.
There really is two.
Okay.
So really it should be
in case of shared bar. Okay.
I have a theory. I have a mental model that I want to try on you, and I want you to tell me if it fits. This is my model. First of all, the analysis has two phases. There is compute a set of accesses, which produces a set mode place. hold on. I'll use some weird pseudo notation here. Where mode is by value ref
Mute ref.
or mute ref. And a place is a place. And then you have what do you call it? Minimization?
Yeah, min analysis.
It takes
Min
S,
capture analysis.
yeah, let's call it min analysis. That takes S and produces a set S prime of captures, right?
Yes.
And so that's the first step. I think looking just at this first step, computing a set of axes, I think if we do not, let's say we ignore reborrow, second, let's do it before we have reborrow. If we have a move closure for any access underscore P in the closure, we create an access in S like move truncate P. Or maybe the truncation takes place elsewhere.
So I was going to say, so some truncation to some degree happens as part of the min analysis. Because truncation can happen on not just for move. We might be truncating for unsafe
Okay.
access arrays.
Fine. Maybe we don't need it. I thought it had to happen here, but now I think it doesn't. So this is kind of my model. Basically, the effect of a move closure is that all the modes, all your accesses become moves.
Yes.
So far, so good.
Yes, all accesses are actually initialized with move in that case. So yeah.
All what?
All accesses and are already initialized with move, if I remember correctly, by value capture.
All
in case of move
are
closure.
initialized with moves. Is that not what I just said, or is that different, or is that the same?
Oh no, I'm saying we don't add, and we don't change it later. It's just initialized that way. But I think I think it's correct. Like the end result is the same. Yeah.
Yeah, I'm just kind of giving a like mathematical model for how it works or something, not necessarily how the code literally works. But now here's the big change, basically, is with reborrows, I think all we have to do is change this part to say, if M is mute ref and P contains the deref of an and mute, add mute ref P to S. Else if M equals ref and P contains a deref of a star, this may not be exactly right, but it's the same because I don't know, there could be more than one ref, but I think it's roughly right. Else, yeah, something like this.
So again, sorry, go ahead.
I think this will match all our examples.
So my question for this one is, when do we drop the derefs versus when do we do this?
Well, okay, so I was going with your assertion that, what is this called, min capture analysis?
Yes.
Will reconcile accesses to overlapping paths. And for moves, it will truncate to at derefs and check for, and in general, so for moves, it will truncate at derefs. And in general, if you have, an access to P and an access to P.Q, some suffix P.Q, we prefer P.
Okay, I see. Okay, so this is where I was a little confused, and this is why I had made a comment about if you look at the first, where you say first part computing a set of accesses before reborrows. So we initialize things to be a move the moment we see them, and we don't actually maintain a state of what's the way to put it? We don't store if they need to be a mutable borrow or something. So I think that can be changed. So like line 143.
Mm-hmm.
So
Yeah,
basically right now, if it's, yeah.
Go on.
So yeah, in line 143, basically that move is like line 142 is always a move, regardless of any part of the process we are in, as long as it's a move closure. So I see how to fix it. I'm just pointing it out. Like right now, it's not that.
Yeah. So
Just so that if I ever refer to this video again, I remember things, or if anyone else refers to them.
I think that reborrows, in a way, I'm not surprised that you're doing it differently, because I think before reborrows, there was sort of no need, maybe,
Yeah.
for min analysis, or like move closures were a little simpler, you know. But
Yeah, I
now
think
with reborrows, move closures become
Mhm.
they're as complex as non-move closures, in that they may have any kind of capture, and you have to minimize it
Yes.
in the same way.
Yes, and also the reason we would do that is so that we can handle copy types without having to make having to deal with the FN1s and that part, which again I think will be affected here because will it be? Actually, no, it won't be. Never mind. We would have to do that analysis later, I guess then, or something like that. If the closure is FN, FN1s, FN mute. Can we? Actually, no.
Oh, I don't know. I didn't think about that. That analysis is done based on the.
It's done in the first phase. It's done when we are collecting our initial information.
Yeah, well, you could do that. I mean, I don't know how it works, but yeah, you would do that not by inspecting the set S, but by, because you actually want the original accesses for that analysis, right?
Yeah.
Not the
Yes.
set S. Yeah.
Yes.
But if we do this algorithm, like we can go apply it to one of these examples, right? Like, like this one. This is a non-move closure, so that's not so exciting. Let's make it a move closure. Or let's go for our original example. Yeah, what's a good example? We'll do this one, but as a move closure. I think it's a good example. So here, the set S is going to be mute ref S star S dot X. Wait, this is a little bit confused. No.
I think we needed X to be a
mute
borrow.
Be more interesting.
Yeah, I think X needs to be a mute borrow.
Now it's going to be mute ref star S dot X, I guess, and it's going to be move star S dot X dot something. And then the min capture analysis is going to truncate the move to S dot X. And therefore, we can drop the mute ref star S dot X access as redundant or whatever. So we wind up capturing S dot X, which I think is what we expect.
Yes.
And our original example is trivial because there's only one access. It's not very interesting. I guess the only other interesting example would be like this one. And here we actually get a different result because we truncate to s dot y. So we wind up capturing s dot x by mute ref, s dot y by move, star s dot x.
Star s dot x by move. And then we'll convert this to a reborrow of, well, to introduce a reborrow, do we just drop the last dereference? And that is it?
To introduce a reborrow.
Because
No,
we can't express reborrows in terms of places.
yeah, you can. It's just a mute ref capture of star s dot x. That's a reborrow.
Yes, we don't support mute ref. That's an R value, right? A mute ref of a place would be an R value, not a place.
No, the place is star s dot x.
Yes.
The
My
node
question
mute
is,
ref.
yes. My point was, how do I describe, like, once we convert that mute ref to a move at the end, or do we never just, or we don't, or we just don't do that, then that works? Is that what you're suggesting?
Yeah, you're never going to convert that mute ref to a move.
Okay, that makes sense.
The conversion to a move is happening when you build the set of axes, not after min capture analysis.
Oh, okay.
This was actually not.
What do you mean? What do you mean by the set of axes?
I mean this. We're computing a set of axes here that we're going to minimize with min capture analysis.
Yes. Yeah.
And what
Yes.
we're doing with move closures is we're
Just keep
actually
it the way they are.
we're converting them all to move unless they meet one of our reborrow conditions.
Oh, okay. Okay. Okay, that makes sense. Sorry.
And
Yeah, that makes sense.
these axes are only used to compute the set of captures we need, basically. So in a move closure, we're going to say anything we access, we have to move, basically.
Yeah. Yes, that makes sense.
Except for reborrows, right?
Of course. Yeah.
And so here, I guess I wanted to do this example too, which here you have s dot x and s dot y, but I put the mute ref here. So you'll get star s dot x and move star s dot y. We're going to truncate the move to s. So we wind up capturing just s.
Okay. Yeah, this makes sense. I'll try to get the PR. I'll just push the changes that I have. I'll keep the move there. I'll leave some degree of fix me if it's needed for the FN1s change and rebar. Sorry, FN1s are like the computing the closure trade change that might be required. And yeah, the reborrow could be a separate PR.
Okay.
Yeah.
Yeah, I would like the reborrow seems complex enough that I'd like to review it all by itself.
That makes sense.
All right. As far as your other PR goes, we already are. I just R-plussed the migration lint. I will try to review. The other one is ready for review, right?
I need to push a small change, but yeah, I'll do it.
Yeah,
I'll try to do it.
I'd like to get it reviewed
I'll try to do
ASAP.
Yeah, I think it's ready for review. I just like the only change I was making was around how dealing with FN1s and all that stuff, because some truncating might have, like if we truncate a deref, essentially what we'll end up with is like if we are ending at a reference, then it's possible like if you truncate to just an ampersand string, then you don't need to have an, if you're just moving an ampersand string instead of a string, then basically you can have an FN closure versus an FN closure. So just need to handle that correctly is what I was working on, cleaning up there. But yeah, could probably turn that into a PR of its own so that's like concise.
Okay.
Yeah. Yeah, so I'll do that. I'll try to do that today or hopefully tonight. And
So
yeah,
once we do
we
that,
can. Mhm.
maybe we can briefly touch base on what's
Big
the
progress. Okay.
status, like overall status on our roadmap.
Yeah, if
or
we
whatever.
can. Yeah, if we go.
Is
Right,
it in
that
here
works.
somewhere?
Projects.
Oh, very cool. Okay.
That. So okay, so number 22 got merged, and number 32 is. I'll check in with Dhruv if he made the added the test that you had asked him to. So number 22 should probably. Let me check one second. I thought number 22 got merged. Or I know you delegated to Chris and he has pushed the change. So it should be good.
Like it's waiting on Boris.
Okay, yeah, so that's about done. So Chris will start working on number 8 after that. Number 18 is waiting on the immutability change a bit because we get those extra warnings when we add some test cases.
Mm-hmm.
Uh, Roxanne started working on 24 based on discussion from last week. This one, I think, needs a test case, so uh, that's being done. Number 35, the first part, once it gets merged, I'll open a PR for precise capture as well because that's ready and implemented. And I'm gonna start working on the, what is it called? The insignificant destructor stuff as well. If we
Yep.
go on the left, let's take a look. So number 8, Chris will start working soon. Number 29, we discussed. Number 29 and number 28 are sort of, we need to look into just certain specific
Oh, right. Okay.
traits stuff.
Yeah.
27
Right.
will get handled with when Roxanne works in 24. Uh, 33, I think, is just sort of an extension on work that's being done right now, but it's just unsafe code that shouldn't be too hard to extend the current strategy to.
All right. Can you go back to this? What did you say about this one?
Uh,
Roxanne
tw-
working on what?
24. This will go with 24, which is like handling patterns.
Okay. So 24 is like
Like,
threading the place builder and stuff like that.
yes, 24, and then yeah, 27 is just like removing one line once
Yep.
that's done.
Got it. Okay.
If we scroll down on the to-do side, what's left? This is calling a function. This is minor change, and this is debug diagnostics. So this is a minor change that I will that we can do. What's it called? That I think I'm going to assign to Dhruv after he's going to add some tests for async closure. So John Triplet, they pointed out that they asked about async closures and we realized we don't have that many tests for them or any tests for async closures using our features. So I've asked Dhruv to add some tests and just make sure I tested a single case and it works, but just add some of those.
Mm-hmm.
37 and 23 are just extensions of uh, coercing closures to be, sorry, not 37. 37 can be closed actually, because that we handled with the new drop strategy.
Yes. All right. So
This
we can
can be
just
closed.
close it. Yeah. Probably I should
Uh,
comment about why.
yes, probably.
So this
Yeah,
was
the hackmd
solved
is linked, but yeah.
by changing the migration to drop.
Ampersand. So yeah, that's done. And the 23 is just an extension of the fact that if this feature is enabled, we can do more coercions.
Mm-hmm. And I remember
So
I sort of, yeah, there was kind of this question of like,
again, do we want to do this?
how
And
much
we
do we
also, if we
care?
do this, yeah, so this is like a very low priority issue from what I
Yeah.
understand.
Yeah, I feel like if at the end of this is like the lowest possible part.
Yeah, this is like, that's why I've shoved it to the very bottom.
I'm happy if it winds up that the coercion analysis still uses upvar as mentioned. It's okay.
Yeah,
Although
like
it would be better if it didn't. I also think it's a backwards compatible. I mean, there's probably some corner cases where it would break things, but by and large, like if we make the coercions work in more cases, it will just be more code compiles,
nice.
so we can do it later.
Yeah. Yeah, so like the changes that are left are kind of, the main big changes that are left is this reborrow, implementing insignificant destructors and patterns. Everything else is kind of sort of in motion or just like waiting on a bit of other things.
It's pretty awesome. It's
Yeah,
really getting there.
Yeah, it's kind of getting there. I think for me, it's just like every once in a while, like when I'm testing some example, it's just fun for me to just like put the feature flag in and code starts compiling instead of borrow errors. Yeah,
it's going to be I think it's going to be one of those changes that we can't believe we didn't have once we've had it for a while.
Yeah, I can understand. I think it will also make like people who are just starting to write Rust a little less confused about some of these things. At least that's what I think. I had some like, at least when I was reading the RFC, it felt like this could be a beginner roadblock as well. Like some very simple patterns, especially in case of like lambdas within a self block. Sorry, closures. Like while implementing a particular trade, when you do list.filter or something, or list.drain, it might, those ones I think could be.
Yep. I've come around to the idea that sophisticated analyses feel simpler to users a lot of the time. They're not doing the desugaring in their head.
Yes. Yeah.
Yeah. I wish. My only fear, the big fear, is that we'll have a runtime performance problem or something. But
So when I did the initial testing, this feature was doing better. Like if you go into my 2020 status doc.
You mean your perf results?
Yes, the perf runs we did. It was a lot more. It was a lot more green, and the red was an incremental compile, which I'm assuming number 18 fixed to some degree.
Yeah, that's not too relevant. Okay, that's good. I wonder if we'll just have to see. I'm not too worried. You can certainly imagine that some closures get really big. I think
closures can probably
we'll figure it out. I think.
Yeah, we would have to stress test this, I guess, is the proper way to say this.
Yeah, I'm not too worried about that because to some extent I see it also as a migration issue. Like we can detect cases where the number of upvars changed from small to very large and put in a migration there and say like, you know, you may want to take it out because you don't care, or I don't know.
Yeah, or just call the capture or migration macro or whatever we end up introducing.
Right. We are going to have to give it a real name. We can't just. Yeah. Okay. Great.
All right. Sounds good. Thank you.
Thanks. I'm on Roxanne. I don't know if Roxanne's still here, but.
I think she had to drop out.
Okay. Ciao.
All right. Thank you. See ya.